Let's talk about how large enterprises are doing service virtualization these days. Over the last 3 to 4 years, we've noticed a pattern with large enterprises. They will use a variety of software architectures, from monolithic through microservices to serverless architecture. And it's important to notice that tools that fit one paradigm do not fit well with other paradigms. So teams that use a certain tool set for developing and maintaining monolithic-like applications will not use those tools for microservices, or will use different tools for microservices and serverless architectures. So enterprise architecture teams must provide solutions to product teams that support all of those use cases and all of those software architectures. So if you look at the monolithic, microservices and serverless use cases, there's different tools that support them in the service virtualization space. So the traditional service virtualization tool scope is mainly monolithic system with some microservices and serverless use cases, whereas the next generation service virtualization tools cater for most of the microservices and serverless use cases and some of the monolithic system test cases. So if you're testing or developing a monolithic system, you're more likely to be fine or well with a traditional service virtualization tool, whereas if you're working with microservices or serverless, you're more likely to be using a next generation service virtualization tools. However, if you're looking at a large enterprise from an enterprise architecture point of view, large enterprises need to have both of these tool sets available for their product teams. What are those tools and how are they different? Well, there's a few differences between traditional and next generation service virtualization tools. The first one is the traditional tools are typically centrally managed by a team of administrators, such as a center of excellence or an enterprise architecture team. Whereas the next generation tools are typically self-service, part of the self-service infrastructure with templates provided by a developer experience team. When it comes to purchasing the tool, typically the traditional service virtualization tools are purchased by the central team of administrators, whereas the next generation tools are purchased by the large enterprises with the help of developer experience teams or enterprise architecture teams, but typically they're purchased by individual product teams that need the virtual services themselves. When it comes to the traditional service virtualization tools, typically the product teams create them, as well as that's the same case for the next generation service virtualization tools. However, with the traditional service virtualization tools, you also see the use case for the service virtualization team to create the virtual services, so a specialized team creates those services. The traditional service virtualization tools are typically creating a virtual service that are long-lived, running 24/7 in shared environments, whereas the next generation tools typically, they still can do 24/7, but typically the majority of the use case is ephemeral instances spun up based on demand, either locally on your laptops or desktops, and CI/CD agents on pipelines or environments like Kubernetes. The traditional ones are typically deployed on VMs or bare hardware, the next generation typically on ephemeral containers. Traditional ones typically are running in a few shared instances, for example, one sandbox environment and 2 test environments, and the next generation ones run in tens or hundreds of thousands of service virtualization instances, many ephemeral instances running on laptops inside CI/CD pipelines, OpenShift, Kubernetes, etc. And the tool features differ here as well. So the traditional service virtualization tools have very rich user interfaces, support many technologies, support most of the legacy protocols, and partially support the modern protocols, new modern protocols. Whereas the next generation service virtualization tools focus on infrastructure as code and code-driven approaches. They have adequate user interfaces, although not as rich as the traditional service virtualization tools, and they provide partial support for legacy protocols and support most of the modern protocols such as Thrift, gRPC, etc. We've noticed customers and prospects coming to us to Traffic Parrot, both enterprise architecture teams and product teams, after they've had their experiences with using just traditional service virtualization tools, and they come to us because they need help with problems that they faced. And I wanted to highlight a few of those here today for you so that you can keep in mind that this might be happening to you if you're looking at implementing only traditional service virtualization within an enterprise that's most likely to have more tools needed, and the next generation, be it open source or commercial tools needed. So the first scenario to avoid or prepare yourself for would be that the enterprise might have issues with the commercial aspect of the vendor relationship. So what we've seen, customers and prospects numerous times coming to us tell us that the tool that we've adopted, the traditional service virtualization tool, was quite well received by the teams, feature rich and well supported. However, the vendor increased the prices significantly after the enterprise has established the tool, and the return on investment after a few years was not positive anymore for the tool. So selected teams continue to use the costly offering, some of them migrating to open source, and we hear about those use cases because the open source tools are not enough for some of those use cases. They come to Traffic Pirate to support their migration of those tools. So first scenario to keep in mind that you don't want to end up there probably. The enterprise, another scenario is where the enterprise team is seen as legacy by the new world paradigm teams. What we hear from our customers and the prospects that come to us is that selected teams have used these traditional service virtualization tools for basic or medium complexity projects, and the features they saw were adequate and the tool was well supported. However, they've observed that after a while, disappointed with the promises from those vendors of the magic features that the tools were offering. So the tool did not work in real complex scenarios as well as during the sales demos, and the magic features were not as magic anymore, and that resulted in high maintenance cost of those virtual services. And then they also see that teams already using next generation open source service virtualization tools will not engage with the enterprise architecture team pushing the traditional service virtualization paradigm. And they just see them, basically the enterprise architecture team, as obsolete and legacy, and they need the next generation capabilities and reach out to us independently of the enterprise architecture teams. The product teams basically see the enterprise architecture team as an obstruction to providing value to the customers. And if you're on the enterprise architecture team, you don't want to be in that spot. So mind that. And again, we're talking about teams that want to introduce only traditional service virtualization across the enterprise, where it's quite likely that you're going to have these teams that need the next generation tools to support use cases like microservices. Another thing that we see with customers and prospects coming to us is that the enterprise decides to move to microservices, and some of the less sophisticated teams are fine with the traditional service virtualization tool for the enterprise microservices, as we've discussed earlier on that slide where we had Venn diagrams. Some of those service virtualization tools will cater for some of the microservices use cases just fine. However, those traditional service virtualization tools typically do not fit the distributed microservices deployed in ephemeral containers model. The licensing prevents from running tens or hundreds of instances of those virtual services in different places, and typically they only allow for 24/7 shared environments. No local development or testing, no CI/CD, inside CI/CD isolated testing will be running outside of the build agents. No ephemeral Kubernetes or OpenShift environments. And then the enterprise team engages with vendors like us on top of exploring open source options, because we have a licensing model that supports this new paradigm. And there's also another issue to keep in mind, that you might have maintenance issues. So we get teams that coming to us that say that we've made several mistakes early on with these tools that result in high cost, long-term maintenance issues. The teams reach out to us and seek guidance how to resolve those issues. So if you have any of those issues, you want to prepare for them, feel free to reach out to us, trafficpirate.com. I'll leave the details at the very end of this presentation. So if you're an enterprise architecture team that is planning to implement traditional service virtualization across the enterprise, I wanted to show you something that will be probably totally out of your comfort zone, and something that is unlikely to be the case for your enterprise. However, I wanted to show you the other end of the spectrum of what some enterprises are actually doing today, and how they're winning against the competition by implementing microservices serverless at scale. So this is an example of a $30 billion company, global e-commerce company, where they're using Traffic Pirate for their mocking, service virtualization, and simulation purposes. They've got a developer experience team that's helping the developers, thousands of developers and QAs, and they've got a lot of developer laptops and desktops running different platforms, a lot of build agents, a lot of OpenShift, Kubernetes, Docker environments, a repository, and a single traffic powered server that manages all of this, right? So they're heavily focused on local development and testing. So most of the usage is actually on local developers' laptops. Another use case that I wanted to highlight here is a different use case where it demonstrates how some enterprises don't necessarily stick with one or two tools. They allow teams to use several tools across the enterprise. And that's this is going to be counterintuitive for the teams that focus, that are enterprise teams that focus on uniformity with tools across the enterprise. So this is a 20 billion retail bank that have been using traffic power for several years, and they've migrated away from commercial to A for cost-related reasons, and they've moved from virtual machines to OpenShift and microservices to continue the DevOps maturity journey. So they started with service virtualization using a couple of open source tools like Montebank, and they had the majority of the use cases covered by commercial to A. And they've migrated to mostly open source, to Wiremock, Montebank. Some teams still remained on commercial to A, some teams migrated to a different commercial tool, and some of them migrated to traffic powered, specifically the ones that were after microservices, ephemeral containers, and OpenShift use cases. So a totally different example, but hopefully demonstrates a new world for you if you're used to the traditional service virtualization mindset. There are companies doing these things, and it might not be the case for you. You might not need this specifically, but all I'm trying to demonstrate here is that large enterprises are going to have different use cases, and if you'd like to support your teams, please mind that you're going to have to most likely use different tools to achieve that goal. So yeah, if you'd like to stay relevant in the new world of microservices and serverless, which is not that new anymore, it's been around for almost a decade now, but it's moving more rapidly into the large enterprises, feel free to reach out to us and we'd be more than happy to help. I'm looking forward to hearing from you.